Hey everyone, so today we're going to go through anti-differentiation again, but this time on your trigonometric identities. Let's proceed. Okay, so anti-deriving sine square x times cos square x. How does that work? We've got squares. So if I give you, anti-deriving sine square x by itself, just like this, what you actually have to do is use the double angle formula, because we can't anti-derive when you got a power on your trig function. So if that's 2, if that's 3, if that's 4, whatever power it is, we cannot anti-derive. The only power we can anti-derive is if it's by itself, such as this case, sine x by itself. So the power is just 1. What you have to do is, of course, use a double angle formula, and then anti-derive. You get your sine 2x, cos 2x, and such. And then you get your answer. In this case, we do the same thing. Even when you see two of them together, sine square, cos square, apply your double angle formula to both of them separately. So cos 2x, we know, is 2 cos square x minus 1, and it's also 1 minus 2 sine square x. If you manipulate both of these so that you get cos square x and sine square x as a subject right here, then for sine square x, you should get 1 minus cos 2x divided by 2. And for cos square x right here, if you manipulate it, you should get 1 plus cos 2x divided by 2 dx. Okay, afterwards, multiply them out. 2 times 2, 4. 1 times 1 is still 1. 1 times cos 2x is positive cos 2x. Negative cos 2x times 1 is negative cos 2x. We can see the cancellation already. And last one, negative cos 2x times positive cos 2x is negative cos squared 2x. And then dx. Okay, so you can cancel out the positive cos 2x and you cancel out the negative cos 2x, and you end up with 1 minus cos squared 2x divided by 4. You can bring the 4 out of the integrand if you want, but in this case, you can also leave it if you want. Okay. What do we do afterwards? You can see, so we'll bring it out. We'll bring the 1 and 4. We'll bring 1 and 4 out, and what we can actually see is 1 minus cos square. That's the identity rule, right? So 1 minus cos square is sine square. So you can actually write it as sine square 2x dx. Okay, we're getting really close. Sine square 2x, yes. If you see sine square by itself, now you can just use the double angle formula once again to actually solve for this integrand. Sine square 2x, use the double angle formula, cos 4x in this case, because we want the double of the 2x. Cos 4x is 1 minus 2 sine square 2x, still the same formula. If you manipulate your equation right here, sine square 2x should be 1 minus cos 4x divided by 2, and you can bring that 2 outside. So it's supposed to be divided by 2, and we'll bring that outside, so we get 1 over 8. Then you just anti-derive it normally. 1 over 8 still there. 1 becomes x. Cos 4x becomes sine 4x, and it's also negative. You derive the 4x, you get 4, but then you bring it down because we're anti-deriving. So x minus 1 on 4 sine 4x. And that's pretty much it. Expand it out. You should be able to get your answer. 1 on 8x minus 1 on 32 sine 4x. So that's how you do this question. If it's and also, of course, plus c. And that's how you do this question if you're given sine square and cos square together. Just use double angle formula on them separately, and then you'll get one function. So you bring it down to one function, then double angle formula again, then you will be able to get your answer. So that's pretty much it for this video. Hopefully you found something new, and I'll see you next time. Thanks for watching.